All right, hello again, out for two people. So we're continuing on with polynomial functions and expressions today. Hoping to keep this video a little shorter because it's you already know how to do this because you've been doing it for a couple of years, but just kind of a review, doing some operations on polynomials, adding, subtracting, and multiplying. Division is a little bit different. We're going to be talking about division in a different video, but adding, subtracting, it's things you've already been doing. So we're going to zip through this pretty quickly. So adding, subtracting. The only thing to remember about adding, subtracting is to combine like terms. Remember what a like term is. Same variable, same exponent, right? So again, watch your signs, combine like terms, that's it. So if I'm doing the first one, so I have an x to the third term, then I have an x squared term, and then I have a constant term that I can combine. But then I have that single x, he's just going to hang out by himself, and we don't have anything to combine him with. So our final answer here, 3x to the third plus x to the third, 4x to the third, 2x squared minus 10x squared minus 8. And then the minus x, again, there's nothing to combine it with, so he just comes down and stays in the answer, negative 7 plus 8 plus 1, and then that's it, you're done. Okay? And then for subtracting, and I'm going to go down to subtracting, and I'll let you pause the video so you can do the other two on the right-hand side on your own real quick, just for a quick practice. But when you're subtracting, the thing to remember about these is that that minus sign distributes to everything in the parentheses. Okay, so really this becomes minus 8x to the third plus 3x squared plus 2x minus 9, and then you combine terms from there. So your final answer here would be 2 minus 8 would be minus 6x to the third. 6 plus 3 is 9, x squared. Negative x plus 2x is plus x. 1 minus 9 is minus 8. Remember, when you're combining terms, the exponent stays the same. You're literally just combining the coefficients, adding, subtracting. Okay, so I'm going to ask you to pause the video and go ahead and do the other adding and other subtracting question. And then here in about 5 or 10 seconds, I'll just go on and write the final answer for you. Okay, so hopefully you got those. And again, just combining like terms. And the adding question, there's no other y term or y cubed term, so it's just going to come down for the final answer. You can combine the y squared terms. You can combine the y terms. And then we can combine the constants. So that'll be your final answer there. And then again, for the subtraction, again, that minus sign hits all of those. So this really becomes minus 2z squared plus 2z minus 9. So my final answer would just be 1z squared or just z squared plus 3z minus 13 would be your final answer on that. Moving on to multiplying, and again, you've been doing this for a year or 2 or 3, probably since you're in 6th or 7th grade, something like that, or even earlier, possibly. Multiplying polynomials, so everything on kind of on the first 4 here are just binomials. You might know FOIL, you might know the box method, you might know another method. It doesn't matter which one to do. I think a lot of people these days probably use the box method, so that's how I'm going to set up the first one. The rest of them, I'm just going to kind of write out the answer. I'll let you do those on your own, and then we can just check the answers for you. So again, if you use the box method, multiply in the boxes. So that's 10n squared, that's 15n, and then that's 16n, and then that's plus 24. And then just combine your like terms, just like always. So final answer, 10n squared plus 31n plus 24. When you do the one just to the right of that, remember, if there's just a one thing out in front, that's just distributing. You don't need a box method. We're just bringing that 3x squared into each of the individual terms. And again, when you're multiplying binomials, okay, we just said when we're adding when you're adding terms, you can leave the exponent the same. When you're multiplying terms, you're going to add the exponents. So 3x squared times x to the third would be 3x to the fifth. And then 3x squared times 2x squared would be 6x to the fourth. Try that again. And then 3x squared times negative x, negative 3x to the third. And then 3x squared times 7, 21x squared. And that's all I got to do for those. For the next one, we got the 4a minus 3b plus 5a plus 2b. Again, don't overthink it, same thing. So if we got 4a times 5a, and I'm not going to set up the box method, but you're going to get the same numbers if you do the box method. 4a times 5a, 20a squared. 4a times 2b would be 8ab. Negative 3b times 5, that's negative 15. But remember, ba is the same thing as ab. Okay, so I'm going to write that as ab again. And then negative 3b times positive 2b would be negative 6b squared. Even if you wrote that third term as ba, it's the same thing as ab. So we can combine those middle terms. So my final answer, 20a squared minus 7ab minus 6b squared. And then the last one, again, if you want to pause the video, I'll just run through the answer here in about 5 seconds. So on this one, again, box method, FOIL, whatever you want to do, there's no like terms at the end. So you're just going to have each individual thing. 4x to the third times 2x would be 8x to the fourth. 4x to the third times 1. Negative 3x times 2x. Negative 3x times 1. And again, no like terms. They all have different exponents. So that's just going to be your final answer. Now, as we get down to a little more complicated ones, so like this one, so we got 2x minus 5 times x squared minus 5x plus 4. We can do it kind of the way the figure shows. We can distribute the 2x through everything, and we can distribute the negative 5 through everything, combine like terms at the end and get the answer. You could also set up a box, kind of do it the box method way, or it could be kind of a rectangle. So you can do x squared minus 5x plus 4, 2x and minus 5, fill in the boxes, again, combine like terms, get your answer. But I'm going to show you a third way to multiply these things that you might like better. If you're comfortable with the box method or FOIL or whatever, or distributing, keep doing what you're doing. But if you're not comfortable with those, if you've never really been good at those, I want to give you a third option. So, and the third option is just like you used to do like back in third grade. So if I asked you to multiply something like 210 times 32, what would we do, right, back in the day? Well, we do 2 times 0, which is 0, 2 times 1, which is 2, 2 times 2, which is 4. Put a placeholder there, always a placeholder, and then 3 times 0, 3 times 1, 2 times 3, and then you add up 2, 7, 6, and that would be your answer, right? It turns out we can do polynomial multiplication the exact same way. So if you put the big thing on top, so if I do x squared minus 5x plus 4 on top, and I multiply that to 2x minus 5, I do the same thing. So if I do negative 5 times 4, that's negative 20. No carrying, no nothing, just write down whatever it is. Negative 5 times negative 5x is 25x. Negative 5 times x squared, negative 5x squared. We do a placeholder, so always a 0 for the placeholder, and then 2x times 4, 2x times negative 5x, and then 2x times x squared. And then look there, your like terms are all lined up, ready to go. So we have 2x to the third minus 15x squared plus 33x minus 20, and you're done. That's your final answer. Now for the last one on this page, I got two more on the next page, and then we're going to wrap everything up. For something like this, 2x minus 1 times x plus 3 times x minus 4, the best thing to do here is to break it up into two parts, right? Multiply the first two things together. So again, you can do foil, box method, vertical, whatever you want to do, and you would end up getting 2x squared plus 5x, plus 5x minus 3, and then multiply that by x minus 4. And again, we multiply that out however way you want to, whether it's distributing, whether it's box method, whatever. But your final answer would end up being 2x to the third. And my smartboard's kind of going crazy on me. 2x to the third minus 3x squared, minus 3x squared minus 23x plus 12. And that would be your final answer. So I've got two more questions. I'm going to let you guys pause the video one more time so you can see if you can work on the last two. And they're both 3x3 things. Or at least the first one's like a 2x3, and then the second one's a 3x3. This one has the box set up for it. Again, you can do it any way you want to. But if you can pause the video, work these two questions out, and then we'll wrap everything up. Okay, so if you did the box method, and again, it is a nice way to organize things, I'm not going to lie. So if you do it this way, you got 2p to the third minus 6p squared plus 8p. And on the bottom row, you'd have 1p squared or p squared minus 3p plus 4. We can combine our like terms, and in this case, we can look kind of on the diagonals. So we got our p squared terms here, and we got our p terms here. So my final answer, 2p to the third minus 5p squared plus 5p plus 4. And whether if you did it vertically or did it just by distributing, you get the same answer. Same thing on the 3x3. We just start going to town here. Now, when you do it this way, again, if you did it vertically, the way I showed you a second ago, everything would be lined up for you. Here, you got to kind of look at your diagonals again. So, and this won't always happen, but a lot of times it will. So we have our x to the third terms. I've got 3 x squared terms, or c squared terms, I guess, not x. And then I have a couple of c terms here that we can combine. So my final answer, 2c to the fourth plus 7c3. It's minus 19 c squared plus 30c, and then minus 50 would be your final answer here. So that's adding, subtracting, and multiplying polynomials. If you have questions, as always, send a message, talk to your teacher, come in for a little bit of tutoring. Division is coming up next. Until next time, stay safe.